All right, now that you have learned about things like factors, things like multiples, you've learned about how the multiplication of same signs work out and multiplication of different signs works out. Let's see how to apply this in problems such as the ones we have on the screen. All right, number one, that is 7.1. What we're going to do here is, first of all, I want you to get used to this. I need you to understand, first of all, that there are actually two terms here. So I want you to get into the habit of building walls as to separate your terms. So there is a clear distinction as to which term comes first and which one comes second. So 10 to the 3 is just 10 by 10 by 10, and that happens to be 1,000. Okay, and then what we do next is, remember now, when there are brackets and there is an exponent, we have to first go for the approach of BEDMAS. In other words, let's sort out the brackets and then immediately go for the exponents. So we will first do this. We're going to keep this minus here, but we're going to apply the exponent, and let's see what this actually means. This here means you are multiplying -7 by itself. That's what it means. Now, going on, we will then, keep the 1,000 and then keep the minus sign. And now let's multiply the signs here. A negative and a negative clearly gives me a positive, and 7 times 7 gives me a 49. So that's my answer for now. And I will end up with 1,000. Negative times that positive is clearly a negative. So I end up with 1,000 minus 49, which you should be able to work out. That is 951. Okay, so that is the long and the short of this sum. 7.2 should be pretty much obvious as well. I can't help but stress the importance of knowing your perfect squares here. You need to know, in other words, what happens to a number when you multiply it by itself. At least to know that up to 15 maybe or 20. That helps a lot. So 12 squared is 144. Let's keep the plus and go for BEDMAS as well. This thing here means -5 multiplied by -5 multiplied by -5. That's what it means. So this is 144. Let's keep the plus. Now, let's think a little bit here. I don't want you to rush this, okay? I'm going to multiply the negative sign here by negative sign. That gives me a positive. Then I am left with this positive and that negative here. So when I multiply these signs, a positive and a negative, I hope you can see how I get a negative. Okay, that was for explanatory reasons. I was just explaining. So if we are to write our final thing here, sign, it is clearly a negative. Now 5 times 5 is a 25, my apologies. And you multiply 25 by 5, that is obviously 125. So we're going to put 125 there. Again, back to that story, we're going to multiply this positive and the negative, we get a negative. So you have here now 144 minus 125. That should give you something like a 19. So that is your final answer here. And I hope you have understood that. If you have a textbook, try similar exercises. Now, we then move to what we call the square roots. Square roots is a reversal of what we have just been doing. What we just did, we squared 12, we squared 7, etc. So the square root now is asking for the reverse. When we squared 12, we got 144. And when we squared 7, we got 49. So square root is saying what did you multiply, what number did you multiply by itself, rather, to get 49? That is the question. And the square root actually has a funny symbol like that. So this is what that's asking for. So then you will know, well, I multiplied 7 by itself to get 49. So the square root of 49 must be 7. Maybe to give it more depth and understanding, we need to actually be able to write a number, as I said, as a power of a number. And so this is, or as a power of 2, maybe, let me put it that way. So that is 7 in this case, and we write 7 as 7 to the power 2, or rather 49 as 7 to the power 2. And so that becomes a 7. So we need to do the same thing. I need you to ask yourself, what is it? What number should you multiply by itself to get 64? Go figure that out and see if you can agree with me here. And so I'll leave you to do this. That is 8.2 since I've done 8.1. Okay. Cube root, again, the same thing. If you remember in the previous question, we worked out 10 to the power 3. 10 to the power 3 basically was a result of multiplying 10 by itself 3 times. Okay, so again, that is the big question they are asking here. What number would you have multiplied itself by at least 3 times to get 125? So again, the symbol for the cube root is almost like the square root, but there is a small 3 there. So you want to find that out, and you will obviously, if you know your cubes, you will figure it out. Otherwise, there's a little calculator trick, which I don't think it's a good idea to show you at this stage, but this will be 5 cubed. You'll probably experiment, and the answer here will be 5. So go ahead and figure out what the cube root of 216 should be. As you can see, these questions here are exactly the same as the previous questions. They are just asked in terms of the actual symbol itself, the symbol, square root, and cube root. So I'm sure you'll be able to do this. Let's quickly go over this, the exponents ones. What's happening here? Again, it's up to you how you want to do this. There's a number of ways. If you know laws of exponents, you will be able to figure this out real quick. But if you do not know laws of exponents, again, let's comply with BEDMAS. Okay, so 3 squared, then thing inside the bracket, it's a 9. Now I have to cube the 9. So in other words, I must multiply 9 by 9 and by 9. And I believe at this stage, the understanding is more important than the answer. So please learn to show all steps. Same thing here, if I apply BEDMAS, I would want to multiply the 7 by 3 first, which I know gives me 21, but that is squared. So that means 21 multiplied by itself. And that is something like 441. Okay, same thing here, same story here. Remember, when you see a division sign, you must learn to use the division line, the vinculum. Now, 3 to the 5 means 3 multiplied by 3, multiplied by 3, multiplied by 3, at least 5 times. And 3 squared means 3 by 3. Now, this 3 can take care of that. This 3 can take care of that. And what are you left with? You are left with 3 3's, which is actually 3 to the power 3, and that is a 27. Again, those who have learned exponents will be able to do this in a quicker way. So similarly, I want you to try this. Find out what the answer will be if you try that. Okay. Another one, true or false question here. Well, you are given 2 statements. You have to tell which one is true, which one is false. And they are testing your knowledge of the distributive property and the commutative property. If you look at this one here, we have the exact same numbers and we are just multiplying them, but in a different order. There's 65, there's 54, and there's 54. Maybe I should also color that 65 and there is 20 here, and there's 20 there. So as you can see, these are exact same numbers. We have just changed the order of multiplication, and we know it doesn't matter. So this is actually true by the since it is the commutative property. But if you look at this one here, this is definitely false. You can even check in the calculator. What they want to check here is whether you actually understand the distributive property. So the correct statement here should be, well, this is 45 times 5 plus 45 times 9. That's what they are testing there. Now, prime factors, how do we find the cube root? First of all, you need to use either the ladder method or the tree method to prime factorize this. So obviously the smallest prime number is 2. You're going to start with 2 and check what comes up and all that. And at the end of the day, I want you to again see if you still remember this. At the end of the day, you will realize that 1728 can be written as 2 to the power 6 times 3 to the power 3. Now, what are we looking for? The cube root. So the cube root basically says we must find this. And what actually happens is we must divide each exponent here by 3. That's what cube root means, whereas square root means you divide the exponent by 2. So if we divide that 6 by 3, we're going to get a 2. If we divide that 3 by 3, we're going to get 1. And so we end up with 4 times 3, which means the answer here should be actually a 12. Take note, they have given a clear instruction that you're not supposed to use a calculator for this question. All right, moving on. These are some of the typical questions also that you would possibly get in an exam. And again, they usually come with the instruction without using a calculator. So if we do this real quickly, BODMAS is very important. Take note, this is a separate term. So that's just minus 6. Here you got to multiply negative and negative, you get plus 7 and a plus 2. I'll leave you to write the answer. Once again, here you're multiplying everything. Signs are very important. Negative and a negative is a positive because we're multiplying the same signs. So you'll be left with 4 times 2 times 3. That's it. Again, BODMAS, very important here. So I'm going to build a wall there. So don't get tempted to do minus 2 plus 5 there. First of all, you have to observe the division sign before addition. So we will write this as minus 10 over minus 2 plus a 5. A negative divided by negative is a positive, and 10 over 2 is a 5. So you end up with 5 plus 5, which I'm very sure you know what it is. Okay, now the cube root of 216 plus that should also be pretty easy. Again, here I want to warn you, take note, there is a wall here. So you must figure that out first and this separately, and then you can finally add them up together. All right, those are the main important things there. Let us look at this one, write in expanded form and calculate the answer. What they mean here is since negative 3 is raised to the 3, so you must expand it like this. And then do that with the 4 as well. And guess what? Do that with the negative 2 5 times. Negative 2 5 times. And then you work that out. When it comes to laws of exponents, I'll discuss 2 quick laws. The first law actually comes from what we have just done earlier on. Let us start with this. If I multiply 3 by itself 4 times, you have noted by now that we can write it as 3 to the what? 4. Okay. Now we noticed in the previous question that we had 3 to the, I think we had 3 to the 5, and we divided this by 3 to the 3. So what happened? We actually wrote 3 times 3 times 3 times 3 times 3 over 3 times 3 times 3. And we ended up with an answer. I think this was squared, but it's fine. We have cubes. In this case, we'll have 3 times 3, which is just 3 squared. But this is not an accident. Actually, if you notice, the bases here are the same. So this is actually 3 to the 5 minus 3, which is 3 to the 2. So we established a very important law here that is called the quotient, because you are dividing, and it says when you are dividing the same bases, okay, this is base 3, that's base 3. So when you're dividing the same bases, just subtract the exponents. That's what it says. The first one, which we actually see often, we do it unaware, is the product one, the law of products. And this is what it says. So suppose I have, again, let's use 3. I'm multiplying 3 to the 3 times 3 to the 2. What does this mean? It means 3 must be expanded 3 times and 2 times again. But I have 5 of them, so this ends up in 3 to the 5. But again, is this an accident? Not at all, because what happens here is if you keep the 3 and add those 2 exponents, you have 3 to the 5. So this is the law that says now, if you are multiplying powers and bases are the same, just keep the base and add what? The exponents, okay? That's what it simply says. So this here will be applying laws of exponents. I need to also take note. If you have a negative sign to an odd number, then the result will be negative. But if you have a negative sign raised to an even power, the answer will be positive. So I'm saying this because I'm seeing the negative 42 here. So I need you to know the answer will be negative 42 to the power 3. Here, what is going to happen, we're going to apply this law. I've kind of done this already. Here, you're going to write this as 5 to the 13 over 5 to the 10. Bases are the same, just subtract. And so 13 minus 10 is a 3. That is basically what you're going to do here. I want you then to explore and see if you can do 3.2.4. That is actually a law that is called power to a power. Probably difficult, and I think I should probably do it for you here. This is what it says. If I have 2 different bases and raised to a power, if the bases have the same exponents, I can actually multiply them, because look at this, 3 and 5 have the same exponents there, so that is 15, and that is squared. So you're just squaring 15 here. And if you don't know your powers again, you will see now the importance of knowing the powers. I think this is 225. All right. Okay, that's the long and the short of my story on this exam revision. I hope you find this insightful. Do comment and like, subscribe to this lovely channel, because there are surely more updates to come and you don't want to miss out on those. Stay tuned.